Stop! If you've ever written the same line of code 5 times in a row, your keyboard deserves a vacation. There's a better way. It's called a for loop, and after today, you'll never go back to copy-paste coding again. Hey friends, Saeed from Elite Tech Club. If you missed my introduction to loops video, go watch that first because it'll make this one way easier. Ready? Let's loop. Imagine a quiz app with 100 questions, or printing receipts for 1000 customers. Copy-pasting is not a solution. Loops are. They repeat tasks automatically until you tell them to stop. That's the whole point. The for loop is used when we need to execute a block of code a fixed number of times. It consists of 3 parts: initialization, condition, and final expression. First, initialization. This runs once at the start. We usually set a counter here. Second, condition. If this is true, the loop runs. If false, it stops. And finally, final expression. This runs after each iteration. Often we increment, but it can do any update. It can increment, decrement, increment by 2, or something custom. Alright, let's break this down step by step so you can really see what's happening behind the scenes. First, we start with let I equals 1. That means we create a variable called I and set it to 1. Now we check the condition. Is I less than or equal to 5? Yes, it is. So we go inside the loop and run the code inside the curly braces. That means we print I, which is 1, to the console. Once that's done, we move to the last part of the loop, the update step. In this case, I++ means increase I by 1, so now I becomes 2. We go back up to the top and check the condition again. Is 2 less than or equal to 5? Yes, so we run the code again, print 2. Then increase I to 3. And this keeps going, check, print, increase. So we'll see 3, then 4, then 5. But here's the key part. When I becomes 6, we check the condition one more time. Is 6 less than or equal to 5? Nope. So the loop stops. No more console logs here. We're done. And that's the magic of a for loop. It runs your code over and over until your condition says stop. Let's begin with a simple example. Imagine that we have a quiz app with 5 questions and we just want to log the questions number in the console. So we can use a for loop, for then our counter here. We start from 1, then our condition. We have 5 questions, so it should be less than or equal to 5. And finally, our final expression or step. Curly braces, then console.log. We can use a string concatenation, question, number, and we concatenate that with the counter, which is I here. I'll save it and let's see. We go to the console tab. Here you see we have question number 1, 2, 3, 4, 5. So our loop is working as expected. Now let's see a more practical example to really understand the power of loops. So we are going to sum numbers from 1 to 1000. Without loops, it's very difficult to do it manually. So I'll comment out these lines. We need a variable to store this sum. So let sum, which is 0 at the beginning. And then here we have our for loop. Now let's use a different name. Number starts from 0. We go all the way to 1000. Of course, we start from 1. And we increment it after each iteration. So here we can either use this, so we can add the previously calculated sum to the current number, or you know that, use our nice assignment operator, which you already know, plus equals number. So I'll use the second one. These two lines are exactly the same. So finally I should like that in the console.log and our variable name. Here I save it, and you see that sum of numbers 1 to 1000 is 500,500. So that's the real benefit. Loops do the heavy lifting for you. One important note here is that we don't have to always start from 1 or 0 and then increment our counter by 1. We can do it in a different way. So in this for loop, if we want to only calculate the sum of even numbers from 1 to 1000, we can start from 2 this time, and we can update our counter and increment it by 2. Then here we will have sum of even numbers from 1 to 1000. Then I'll save it, and here is our result. Needless to say that we don't have to always move forward, we can also move backward. So start from, for example, 10, and let I, which is 10, and then until 1 is greater than 0, we decrement the counter and then log the counter. So console.log, I'll comment out these lines and save it. Oh, I forgot to comment out this one. That's why it's complaining. Here you see we start from 10 and 10 all the way down to 1. Now let's introduce break and continue. Break exits the loop immediately. Handy when you found what you need and don't want to keep searching. Continue skips the rest of this iteration and jumps to the final expression. Then back to the condition, useful for skipping bad data or exceptions. Let's say we want to find the greatest number below 100 that is divisible by 17. So we can start from 100 and then count down. And when we find the number which is divisible by 17, we are done. And we shouldn't, or we don't need to check other numbers. So I'll comment out this line. Let me also add a description, greatest number below 100 divisible by 17. For I forgot the let keyword. We start from 100 and then we decrement the counter. Here's the important part. So we should check if this number, or our counter, let's say, is divisible by 17. So you need to use the modulo operator. If this is the case, we can log in the console.log. Found it. And then that number. And since we are done here, we don't need to go through the rest of the numbers. So we can use break and exit the loop. And finally, we can also add another console.log. I'll save it, and here you see that it says found it, and it's 85. Now let's say we want to print all the numbers from 1 to 20, but skip those which are divisible by 3. This is a good use case of continue. So let me first comment out these lines. So another loop, we can also get some help from the IDE. Index from 1 to 20, and then we increment that. And here we need to check if this index is divisible by 3. Then continue. So skip this iteration, else we log the number in the console. So we log this index. Okay, cool. Now let's see. So we have 1, 2, we skipped 3, 4, 5, and then 6 is also escaped all the way to 20. So we missed equal here. Here you see that we also have 20, but we skipped all of the numbers which are divisible by 3. We can also get rid of the else statement because, as mentioned, whenever we use the continue inside of our loop, then other statements will be skipped. So we can also remove it and the result will still be the same. So I'll save it and you see that nothing changes and it's working as before. Common pitfalls and tips. Forgetting break and continue intent. Use them intentionally. Off by 1 errors. Always check the comparison operator in the condition. Infinite loops. Make sure that your final expression will eventually make the condition false. Otherwise, your loop will keep looping like a DJ stuck on one track. The only party people don't like. Your challenge. Write a for loop that counts down from 10 to 0. Skip number 5 and break the loop at 2. Add a fun message to each line. Be creative. Post it in the comments, I'll pin my favorite. Quick recap: initialization, condition, and final expression. And remember, final expression can be anything. Use break to stop early and continue to skip an iteration. Loops save you time and make your code powerful. If this helped, smash that like, subscribe, and check the Introduction to Loops video if you haven't already. Next up, while loops. They're coming. Until next time, keep coding, keep looping, and stay awesome.